Okay, so we're going to be looking at percent yield. It's really just one more fairly straightforward, simple step on top of what we've been doing. But basically what we're looking at is when you have a reaction occur, you can calculate what your theoretical yield is according to the math. But almost always you'll get a little bit less produced just because in most reactions there's some things happening with the molecular architecture of the way those things go together. And you just don't get everything produced that you maybe should. At best, you'll see 97, 98% yields, usually, oftentimes even lower than that. So anyways, as an example here, we're going to look at a aqueous solution of cadmium chloride reacting with sodium sulfide solution. So that would be a double replacement. And this is going to be a precipitation reaction. So we end up with a precipitate of cadmium sulfide and then aqueous solution of sodium chloride. So you would first write out that equation, make sure that you're writing the formulas correctly, and then balance it. And then it says we're going to have 1 gram of cadmium chloride used up. So we know we're going to use up all the cadmium chloride. That's our limiting reactant. It doesn't even matter how much sodium sulfide we would need. We're using 1 gram of this. So we want to know how much cadmium sulfide is going to be produced. So we want to go from grams of cadmium chloride to grams of cadmium sulfide. So first go from grams to moles of the cadmium chloride by dividing by the molar mass. Then you're going to go from moles of cadmium chloride to moles of cadmium sulfide by looking at the mole ratio. In this case, it's 1 to 1. And then once you have moles of cadmium sulfide, we can convert to grams, and that's by multiplying by the molar mass of cadmium sulfide. Calculate that across, and we would get a theoretical yield of 0.788 grams of cadmium sulfide. And then if we actually did this as a lab and you dried out your resulting product, if we found that we had an actual yield of 0.775 grams and we want to calculate the percent yield, you just take the mass that you've got for the actual yield divided by the mass of the theoretical yield, and then multiply by 100 to make it a percent, and you would end up in this case with a 98.4% yield. If you have an actual yield, sometimes this happens in the lab where you end up with an actual yield greater than the theoretical yield. So you actually end up with a percent yield greater than 100%. Now this usually doesn't mean that you actually had this happen. It means that you made a mistake, and 99% of the time, if you're especially dealing with solutions that you're drying out, what you did here is that you ended up with an incomplete drying of your sample. So you still had some water in there, so it made a false percent yield greater than 100%. Second example down here, we've got nitrogen and hydrogen combining to form ammonia. You're given 25 grams of nitrogen gas, 5 grams of hydrogen gas. And we want to first figure out what the theoretical yield of ammonia. Now in this case we're given masses of both reactants, and we're going to have to first figure out what's limiting in order to figure out which one to use to find the product. So this is really good review of that process. So first let's work from the nitrogen. I put the 25 grams of nitrogen above there. So we're going to go from grams of nitrogen used, assuming that that's limiting used all the way up, and then figure out how much ammonia is produced. So grams of nitrogen goes to moles by dividing by the molar mass. Now this is a diatomic element, so you got to be careful of that. So nitrogen here, you have to use twice the mass of nitrogen because it's N2, not N. That gets us to moles of nitrogen, and then we're going to multiply by the mole ratio. So it's 1 mole of nitrogen for every 2 moles of ammonia produced, and that's from balancing the equation 1 to 2. And then once we have moles of ammonia, we can go from moles to grams by multiplying by the molar mass of ammonia, and that would give us 30.4 grams of ammonia if all 25 grams of nitrogen was used. So if that was the limiting reactant. Then we want to look at it as if hydrogen was the limiting reactant. So using up all 5 grams of hydrogen, you're going to divide by the molar mass of diatomic hydrogen, so 2.02 grams, mole ratio of 3 hydrogen to 2 ammonia, and then going from moles of ammonia to grams, similar to this last step up here, and we would get 28.1 grams of ammonia. Since that produced the lesser amount from these two options, we know that the hydrogen was the limiting reactant, and we're going to end up with the 28.1 grams of ammonia. And then if the percent yield of the reaction is actually a 94.5%, we wouldn't get all 28.1 grams of ammonia produced. You would have to take that 28.1, multiply by the percentage in decimal form to get the actual yield, which is 26.6 grams.